next time I see you. Substitution and elimination. And we will have to follow the instructions. So one problem will say, use substitution. Make sure you use substitution. The other one will say use elimination. All right, so let's review that. Make sure you all remember how to do that. We did some in our notes. We actually have a homework assignment with a few of these. All right, so here we go. What is the procedure for substitution? I gotta get something by itself. And I always just kind of look at it, see how the x has a 2, this y doesn't have anything, this has a 3, and this has a negative 2. So I always like to go for the thing that's already by itself. So I'm going to rewrite this equation, y equals 10 minus 2x. And then I will take what y equals and substitute it in for y. So my bottom equation will now look like this. So I got y by itself. You can get anything by itself. It doesn't matter. But if you try to get these other things, you're going to have fractions. That's okay, but you got to deal with it. So I got y by itself. And then whatever y equals, I plug it in for y. Alright, so now I'm going to do my distributive property very carefully. So that's going to be negative 20 plus 4x. Right? And then 7x minus 20 equals 1. Which means 7x equals 21 and x equals 3. Now, remember how we write our answer. Our answer is going to be an ordered pair. Always, always, always an ordered pair. And at this point, all we know about that ordered pair is that x, which comes first, is 3. Alright, so what do I do? Plug it in somewhere, right? And it doesn't matter where. I'm going to plug it in right here. If I put 3 in there, then doesn't this say 10 minus 6? Which is 4. And if I have time on my quiz, I can check that. Because if I put 3 here and 4 here, I should get 10, right? Or if I put 3 here and 4 here, I should get 1. That's your check. You can plug it back in and make sure. Any question about substitution? All right. Problem looks just the same, not the same problem. It looks the same. This time we are eliminating. Different procedure. What do we do to eliminate? We need to make it so when we add these together, something gets eliminated. Okay, either the x's or the y's. So that is not going to happen right now. What can I do to make it happen? Times what?
2. The bottom by 2.
The bottom by 2. If I multiply the bottom row by 2, okay, so my top row is this, and my bottom row will now be 6x plus 4y equals 14. Now, could you have done something different? Absolutely. But does that make sense to you, what you did? Because these are now gone. Remember, one has to be negative and one has to be positive so that they will cancel each other out. So 7x equals 7, and it looks like x equals 1. Just like before, our answer is an ordered pair. This time, x is 1. So plug it in somewhere. Let's put it in on top. 1 minus 4y equals negative 7. I'll subtract 1, negative 4y equals negative 8. 2. Did you get 2? And I can check that, because if I put 1 here and 2 here, I better get 7. I do. Alright, are we totally clear on what the quiz is next time? Okay? Alright. Now, let's get our notes out and let's finish up our vocabulary. Who can tell me the definition of a matrix? A rectangular array of numbers arranged in rows and columns, right? Now, think about that definition. A rectangular array of numbers arranged in rows and columns. What do you think a square matrix is? What? The rows and columns are the same. So remember the one I had on the board yesterday? I don't remember the exact numbers, but I think it was a 2 by 3. That is not square because it has 2 rows and 3 columns. If the rows and columns match, like 2 by 2, then it's called a square. So what is a square matrix? A matrix that has the same number of rows as columns. We can do stuff with squares that we can't do with others. Okay, so I'm just going to use this guy right here, although I don't like that actually. Oh yeah, that's no. I'm going to use this. I'm going to call this matrix A. Actually, I'm going to call this one B because I think I called it A yesterday. So I'll call this one B. A rectangular array of numbers. These guys are called entries or elements. 2 words for the same thing. Entries and elements are the numbers inside the matrix. That's just what we call numbers inside the matrix. Okay. Now, this is important. The dimensions of this matrix are 2 by 3. We talked about that yesterday. What did we say dimensions were? The number of rows by the number of columns. That's not the times, it's by. Like the room is 40 by 30. By. So we have 2 rows, 3 columns. Let's suppose that I wanted to talk about that number right there, that entry. For some reason, that was special, and I wanted to talk about that. I would refer to that entry with a lowercase b because it's coming out of matrix B, and it would have a subscript, the numbers written down below here, of 2-1. Anybody explain that to me? What does that subscript mean?
Row 2, column 1.
Bingo, row 2, column 1. Remember, in matrices, it's always row, column, first number's rows, second number's columns, Roman Catholic, RC, always, always, always. So when you see a 2-1, there's no comma, there's no nothing, it's just 2-1, that means row 2, column 1. So what would this be? And I have to use a B, because if I used a different letter, I would be pulling my number out of that matrix, whatever it was. These are coming out of matrix B. So what is B sub 1, 2? What is that? That's him. Because this means first row, second column. So that would be 2. All right, what's this one? Don't have it. Why not? There's no third row, right? That would mean look at the third row, and I don't have a third row. Okay, so make sure you're comfortable with that notation. If I were getting it out of my matrix yesterday, which I called matrix A, I would be using a lowercase a. That would tell me A scalar. Vectors and matrices have their own language. And we skipped chapter 6, which was the vector chapter, so we hadn't seen this language before. You have, if you're in physics, a scalar. You know what a scalar is? What's a scalar? A scalar is just the matrix or vector word for a real number. And people, you guys are probably thinking, why don't we just call it a real number? I don't know. Matrices, linear algebra, the study of linear algebra has its own language, and scalars are simply real numbers. Alright? And the last definition we need to know is equal matrices. I want you to tell me, what do you think equal matrices are? What would be your definition of equal matrices?
Numbers the same.
Okay, so let's look at that. So Kyle has put himself out there and he says, okay, what if I had, those two matrices have the same numbers? Would you say they're equal? No, they are not, because what's wrong? The numbers are not in the same spots. Two-part definition, equal matrices. First of all, they have to have the same dimensions. They cannot be equal if they do not have the same size. They must be the same size. They don't have to be square. They can be 2 by 3 or 5 by 8 or something, but they both have to be exactly the same size. And they must have the same corresponding entries. And what that means is, that's just math language for, they have to have the same numbers in the same spots. Same numbers, same spots. Okay? All right. That is all we have time for, because I believe our period is. So we will continue on with our notes next time after we take our quiz. All right, so first.